Hey everyone, how are you? In this video, we are going to solve the Leetcode problem of the day, and the problem is find the original typed string part 2. Now the part 1 of this particular problem was the problem of the day yesterday, and it was very easy. But the part 2 is actually hard, and I would say it is a bit hard, but it's completely fine because I say that whenever it is a hard question, you just need to break the questions into pieces, and all those different pieces are actually very easy. You just need to combine those pieces and you will be able to solve these questions. So let us see what's the input in the problem. The input in the problem is a string. Let us call it as word. And there is another integer and let us call it as k. The output we need to give in the problem is the total number of possible strings that was intended to be typed by Alice of length at least k. This k is given in the input and we need to find what are the possible number of strings which Alice was actually trying to type when she ended up typing this particular word. She might have actually tried to type a different word and we just need to find out what is the number of possible strings that she was trying to type of length at least k. Now the thing is, let me give you a context that what is happening using an example. So in the example, the given word is a b b c c d d and the value of k is 7. If there is a, it means maybe she was trying to type just a single a and just by long pressing she ended up typing a. Or for bb, the same case, maybe she was trying to type b but she ended up typing bb. Or maybe she was trying to type bb only, who knows, right? So we just need to find out what are the different possibilities which she was actually trying to type. You need to find the number of strings which are possible which Alice was trying to type of length at least 7, and for this particular input the output is 5. It means that there are 5 possible strings which are of length at least 7 which Alice was actually trying to type. So for this particular input the word could be aa, that is aa, then bb, then cc, and then maybe just a single d, and she long pressed and typed the d 2 times. So that's one possibility. Or maybe there is another possibility. The first possibility is of length 7. The second possibility is of length 1, 2, 3, 4, 5, 6, 7, 8. So this k is actually the at least value. The length of the string can be more than 7 or equal to 7 but not less than 7, right? So this is of length 8 and that's the original string. So maybe she was actually trying to type this. That's a possibility, right? So that's of length 8. All these strings are of length 7 which are another possible strings which she was trying to type. Now let us try to focus on the solution approach of this particular problem, and as I have told you that if you are trying to solve a hard problem, try to break the hard problems into multiple sub problems. Maybe those sub problems are medium level, but after getting combined it becomes a hard question. So no worries, let us try to break this particular problem. First of all, what you can actually think about is, if you have a string and the question says that forget about this particular constraint, what if you are trying to find out what's the total number of ways to create the original strings which Alice was trying to type if you have no length constraint, that is of any length she was trying to type, find out how many total strings you can create. So the thing is, for this particular word I can say a b c d. This is also a possibility but the length is 4, right? Maybe she was trying to type a, she ended up typing aa. Similarly for b and c and for d. So that's one possibility, right? So like this there are total number of 16 possibilities for this particular data aa, bb, cc, dd. And how can you find it? See, the thing is, where is the mistake? Where is all the logic? The logic is all about pressing a particular keyboard button for long, right? So if you see any continuous data, you can say that, okay, I see that this is AA, but maybe she was trying to type A, or maybe she was trying to type AA, right? So there are two possibilities with this particular continuous data. Similarly, with this continuous data BB, you have two possibilities, CC, you have two possibilities, and DD, you have two possibilities. So there are total 2 multiplied by 2 multiplied by 2 multiplied by 2, 16 possibilities. There are 16 different possible strings which Alice was trying to type. Now this is the first thing which we need to take care of. We should know what's the total number of ways you can type a string regardless of any length constraint. Later on we are going to apply the length constraint, but for now let's just find out the total number of ways. Now one of the way we can solve the problem is we can just create all the possible 16 strings. We know there are 16 strings, right, which are possible. We can create all possible strings and then we can say, okay, let us return the strings of length which are more than equal to k, or maybe just count the number of strings which are of length more than or equal to k. That is going to give you the output, right? So all the logic is just how can we create all the possible 16 strings. But the thing is, do not even try this. Why? Because this is for sure going to fail for bigger inputs. This is a brute force approach. And how can you say this? See, the thing is, right now the string is of length 8, right? For the length 8 you have 16 possibilities. Let us say the length of string is nothing but 100, okay? Just 100, because the question says that the length of string can be 10 to the power 5. So 100 is a very small example. For a length of 100, maybe the first 10 characters are A, then 20 characters are B, then let us say 30 characters are C and 40 continuous characters are D. Now if you try to find out the value of this, so it is around 240k, 240,000 loops just for an input of 100. For a word of length 100, you will have to create these many strings, and out of this you will again have to do a loop to check what are the strings with length more than equal to k. So that's for sure going to give time limit exceeded error. Maybe this can blow up the system, so do not even try this. Now if we cannot create the strings, that's for sure we cannot create, right? Then what can we do? See, the question says that you just need to find out the count, right? So can we just count? Can we count how many strings we can create of length more than equal to k? See, the thing is, we can count how many total number of strings we can create, but out of this total we need to find out a way so that we can just count the strings of length more than equal to k. So another question is, can we find smaller length count easily or bigger length count easily? What I mean to say is, see, the thing is, if your string is this A, B, B, C, C, D, D, right? And you have a total possibilities of 16. Now you need to know that you will have to select at least one A, at least one B, at least one C, and at least one D, right? And why so? Because you cannot skip any character. If Alice is trying to type something and she ended up typing multiple C's, then for sure she was trying to type the character C. She just long pressed it and typed it multiple times, but she was actually trying to type it at least once. So for sure 1A, 1B, 1C, 1D. So the minimum length is going to be 4, right? That's the minimum length string Alice was trying to type. Now my question is, can we find the smaller length count easily or the bigger length count easily? The maximum length possible is 8, right? The original string. The minimum length is 4. So I know that all these 16 strings which are possible will be of length 4, 5, 6, 7 and 8. I need to find out the strings which are of length at least 7 or 8, right? Now there are two ways. You can directly count the strings of length 8 or 7, or maybe since we know the total, and if we can count the number of possible strings of length 4, 5 and 6, then what we can do is we can just say, okay, you can remove the count of strings of length 4, 5 and 6 from 16. That's like saying that if you have 4, 5, 6, 7, 8, these are the possible strings. If you can find how many strings you have of length 4, 5 and 6, and we know the total, so I can say 16 minus the number of ways we can create the strings of length 4, 5 and 6. And that is going to be equal to the number of original strings which Alice was trying to type of length 7 or 8, right? And the thing is, it will be easy to count the smaller length, and that is because, let us say I ask you right now that, can you find out the string which is of length 7, exactly 7? Then there will be a lot of confusion. Maybe you will have to take one number of A, then all other characters, and then one number of B and all other characters, or maybe one number of C and all other characters. So you will have to think a lot. But if I ask you that, hey, can you tell me how many strings we can create of length 0? Then it is very easy. It is just one way to create a string of length 0, that is an empty string. An empty string is of length 0, and that's the only way we can create a length 0 string. Okay, what about 1? Can you create a string of length 1? Of course we can do it. And there is just one way. Directly we can find out. That's because the first character was for sure Alice was trying to type. So a string of length 1 will be nothing but A, right? A string which is having one character A. So it is a bit easy to calculate the strings of smaller length, and using those smaller lengths, we are going to calculate the bigger lengths. And this is called dynamic programming. You might have heard about this. People say that this is called DP. I would say this is called dynamic programming. Basically, both are the same thing. And why I am saying this is DP, that's because we are trying to build the solution for a bigger problem using the smaller problems. I am trying to find out the number of strings I can create of length 1 using length 0, of length 2 using length 1, of length maybe 7 using length 6, right? So this is the way I am trying to build the solution, and let us see the approach. We know that we can create smaller length count easily, right? That's my string, the input. The total number of ways are 16. Now we can actually create groups of different characters. And why I am saying this? That's because this is a group which is going to contribute some answer. This is another group. This is another group. And this is another group. Now this group and this group have nothing to do with each other, right? Because I know that I have to take a minimum 1 character from this, a minimum 1 character from this, a minimum 1 character from this, and a maximum of 2, right? A minimum of 1 and a maximum of 2 characters. So let me create a group of these characters, and basically what I'm trying to do is I'm trying to just separate them, and I say, okay, it is AA, BB, CC, DD. And then I'm trying to store the length of these strings in groups. Now I will try to find how many words of max length k minus 1. That is, if the value of k is 7, how many words can we create of maximum length 6? I know the total number of ways, it is 16, right? I know the output for this particular input as well, it is 5. That is, I have 5 different strings of length at least 7 or 8 which are possible, which Alice was trying to type. So there are 11 number of strings which are of length at most 6, that is max length 6. The length could be 4, 5 or 6. There are total 11 different strings which are possible, which Alice was trying to find. So I can say 16 minus 11 is equal to 5. I need to find this value 11. I need to find a way to find this 11 value, so that I can say 16 minus that 11 or whatever value we can find. So we can say output is equal to the total count. This is the total minus, that is minus k ways. Let us say this particular value which we are trying to find out is k way. I mean, you can assign it any name. So let us say it is k way. So total minus k way. Now the value of k is equal to 7. We need to find how many ways to build strings of length at most k minus 1. And we know that the minimum length of our string is going to be the length of the groups. We have 4 groups, right? 1, 2, 3, 4. We have created an array or a list of the group's length, right? 2, 2, 2, 2. 2 means this group is going to contribute maximum of 2, minimum of 1 characters. And since 2 is the value for all the groups, this is the same for all the groups. Now I'm saying that the minimum length of my string which Alice was trying to type is length of the group. That's because if I have 4 groups, each group is going to contribute a minimum of 1 character. I have 4 groups, I can say length of my groups, which is nothing but 4, right? So the minimum possible length is 4. So initially there can be a check that if the minimum length we can create is more than or equal to k, the given input k, then all the strings which are possible, which we can create, are going to be the possible strings which Alice was trying to type. So we can directly return the value of total, no need to go ahead. Let us say for this particular string, the value of k is equal to 4. Now I know that there are 16 ways to create possible strings which Alice was trying to type. The minimum length string we can create is 4 and the value of k is 4. It means try to find out all the strings which are more than equal to 4. I'm talking about the length. So all the strings will be of length at least 4. So 16 is going to be the answer, right? So that is what I'm saying. Minimum length is going to be the length of the groups, and if it is more than equal to k, return total. That's it. But what if this is not the case? And that's what we are trying to solve. Initially what will happen is, let us say we are trying to create a string of length 0. A string of length 0 will be an empty string, right? This one. So there is just one way to create a string of length 0, that is this empty string. I want to find out how many ways I can create a string of length 6, because the value of k is equal to 7. So find out the number of ways to create strings which are of length at most 6. So I know that an empty string, we have one way, right? This is the base case we have. We have one way to create a string of length 0. Now to create a string of length 1, I know that there is at least one string which is of length at most 1. I mean, this empty string is of length at most 1, right? Is of length at most 2 as well. If I ask you, try to create a string which is of length, max length of 6. So I can say an empty string is also satisfying this condition. It has a max length of 6. The maximum length is 6. The minimum can be 0 as well, right? So initially we have one strings which is of length 0, 1, 2, 3, 4, 5, 6, right? And this is called the prefix sum. We know that for string of length 0, there is one string. For 1, this will be 1 plus 0. Then for 2, it will be 1 plus 0. Then for 3, it will be 1 plus 0. For 4, it will be 1 plus 0. 5, 6, all the way along. So we have a total of 1 strings which are possible of each length, right? I'm talking about max length, right? Now let me try to process each of the group. The first group is having a length of 2. Basically the characters are a and a. And currently what we are trying to do is, we have this prefix sum. This prefix sum is telling me that a string of length at most 0, we have one way. A string of length at most 1, we have one way. Similarly, a string of length 6, at most 6, we have one way. We just have one string which is empty. Now what we are trying to do is, we are trying to say, as of now we have not seen any characters. Now let us see the first group which has the character a, and it is total number of 2 times. Now tell me, how many ways do you have if you select characters from this group? How many ways can you create a string of length 0? See, the thing is, we will at least select one character, and at max we can select 2 characters, right? We can say from this particular group I can select a or a, right? These are the 2 possibilities. So to create a string of length 0, I have 0 ways, right? Now I cannot create a string of length 0 because I have some data. I will have to select at least one character. But I have one way to create a string of length 1, that is a string with just one character a. And I have one way to create a string of length 2, that is a, right? So as of now what we have is, I have one way to create a string of length 1, one way to create a string of length 2. Now my prefix sum will be updated, and what this will become is, this will be 0, this will be 1, this will be 2, because 1 plus 1, which is 2. So this will be 1, this will be 2. Now we have 2 plus 0, which is 2, then 2 plus 0 is 2. So all the values are now going to be 2, right? So after processing this first group, what I have is, I have 2 different ways to create a string of length at most 6. And those 2 strings are nothing but a and a. This is after processing the first group. But we have more groups as well, right? So the next group is bb, right? Again, we will select at least one character and at most 2. Now again our dp table will be reset to 0, 0. See, the thing is, there is a formula which I am trying to derive, which I will tell you what's the formula. But for now, before you know the formula, you should know the actual way, right? So that is what I'm trying to do. Now again the same question. Try to find out how many strings you can create of length 0, 1, 2, 3, 4, 5, 6. Of 0, you cannot create any string because right now what we have is we have A and AA already created, right? We have these two strings with us. These two are the possible strings we have of length at most 6. Now I have to select at least one character from the new group. If I have to select at least one character from the new group, then I will add, let us say I select one character B and add it to this group. It will be AB, right? AB will have a length of 2. And if I add it to this particular group or this particular string, this will be AAB, which is of length 3. Now I cannot create a string of length 1 anymore because right now I have seen two different groups. So I will have a string of length at least 2, and I have one possible way to create a string of length 2. Now I have two possible ways. We have A, then I have AB. If I can select one number of B from here, right? So I can say I have two number of ways to create a string of length 2, right? Also what I can do is I can create another string which is A and B. These two strings are added to our list, and these two strings are nothing but strings created by our previous strings by adding one B. What if I add two number of B's? Then it will be A, this particular A, then two number of B's, and I have this particular data A, and then BB. So our previous answers will be gone. Now these are the four possibilities we have. We have a string of length 4 one times. We have a string of length 3 two times, I would say, and we have a string of length 2 one times now, right? So this will actually be 1, and that is because this particular A is not valid. If we have seen two characters A and B, so AA cannot be the string which was intended by Alice to be typed, right? So this will not be valid. We can get rid of this, right? Now these are our valid strings as of now after we have processed A and B, right? We have processed A and BB, and this is the data we have. Using this, we can again update our table, and we can say our table will be number of ways to create a string of length at most 0 is 0. Then it will be this 0 plus 0, which is nothing but 0. Then you have 0 plus 1, which is nothing but 1. Then you will have 1 plus 2, which is nothing but 3. Then you will have 3 plus 1, which is nothing but 4. Then this 4 will continue because these values are 0. So now what we have is, after processing A and B, these two groups, what we have is, we have 0 number of ways to create a string of at most length 0, 0 number of ways to create a string of at most length 1, but there is one way to create a string of length at most 2, and that string is AB. Then you have 3 number of ways to create a string of length 3, at most 3, not 3 but at most 3. So it is 1, 2, 3. You have 3 number of ways to create a string which with a maximum length of 3. 4 number of ways to create a string of maximum length 4. These are the 4 strings, right? And the answer will continue for length 5 and length 6. Now you might be wondering that, okay, fine, as of now I'm able to calculate the values, but what could be the formula? What could be the actual logic for finding out these values? And let's try to get the formula now using the next group. The next group is CC, and that's the third group actually. So it's the third group we are trying to process. Let me reset all the DP table values again. Make it 0, 0, 0, 0, 0, 0, 0. Now if I ask you that, try to find out a string of length 0, how can you find it? See, the thing is, do not try to process for 0 in the DP table because that will always be 0. Okay, if we are processing any character, it will always be 0. But start from 1. For 1, what could be the formula? See, the thing is, if you are trying to find out for 1, okay, you are trying to create a string of length 1, right, by adding at least one or maximum of 2 characters from the third group. So what you can do is, you will have to ask the previous groups before 1 that what's your count, how many ways I can create a group with length less than 1. That is because we are trying to add some characters, right? Once we add at least one character, if I have a string of length 0, if I add one character, this will be having a length of 1, right? So similarly, if I want to create a length of 1 here, I will have to ask Mr. 0 that how many ways are there in which I can create a string of length 0. So there are basically 0 number of ways as of now, right? We cannot create a string of length 0. If we cannot create a string of length 0, we cannot create a string of length 1. That is because we are for sure adding some characters, right? So this will be 0. Now what about 2? Try to create a string of length 2. If you want to create a string of length 2, you will have to say, okay, I'm adding some characters from this group. So I need a string with at most length of 1. Do I have some strings with at most length of 1? No, I don't have, right? So I cannot create a string of length 2, right? This will be 0. Now, can you create a string of length 3? Yes. How many ways can we create strings of length 2 in one way? That is nothing but this one, right? Now, if I can create a string of length 2 in one way, and I'm adding some characters from the third group to create a string of length 3, so I would say in this DP table, to fill the value for a particular length, you will have to say it is equal to prefix sum array. This is our prefix sum array. And I would say prefix sum array then length minus 1. We are going to get this particular formula proved for a lot of different lengths, so don't worry about anything. And there is one more thing which we will see. For now, let us keep it like this. How many strings you can create of length 3? It will be just 1, right? That will be nothing but we have AB, and then we can add one number of C here, and this will be ABC. Just one string of length 3, right? Alright. How many strings of length 4? Okay. To create a string of length 4, you would say, okay, to create a string of length 3, I have 3 number of ways. to create a string of length 4, I will have 3 number of ways. What are those strings? What I can say is I can add 2 number of C here. So it will be A, B, C, C. I can add 1 number of C into this, 1 number of C into this. This will be A, A, B, C, A, B, B, C, right? So there are 1, 2, 3. 3 ways to create a string of length 4. Now, how many ways do you have to create a string of length 5? Okay. Then I have to ask this particular data, the string of length 4, right? That there are 4 ways to create a string of length 4, right? But the thing is, you will have to remember that this prefix sum is not telling me the exact value. This is not telling me that I have 4 ways to create a string of length 4. This is telling me that I have 4 ways to create a string of length max 4. The maximum length of 4 string are 4. There are 4 different strings of max length 4. These are the strings. The length are actually 2, 3, 3, 4, but here the maximum length is 4. So we have 4 ways to create a string of length max 4. So now if you try to say that, okay, how many ways I can create a string of length exactly 5? In this DP table, I'm storing the value of exact. So exactly 5 length string if you want to create, then according to the formula, you would say, okay, I can create string of length 4, string of max length 4, 4 ways. So I can just replace the value here and I can say I have 4 ways to create string of length 5 just by adding some characters from this. But the thing is, it is not correct. I will tell you how. You are allowed to add a maximum of 2 characters, right? Because you have third group has a length of 2. So if the maximum characters are 2, you can add max of 2 characters in your existing strings. I can say I will add this CC, both C in this particular data, which has a length of 2. Even then the length will be 4. 1, 2, 3, 4, right? The length will not be 5. So if you are adding all the 4 number of strings and you are saying these strings can be converted to a string of length 5 using this group, no, not all will be converted. Only this. These 3 groups can be converted to a string of length 5. You can say CC, CC. You can add 2 C's here in this group, and we can add 1 number of C in this one, A, B, B, C, and you can convert it to a length of 5. So there is one more check which you will have to do. That's because you will have to see that right now I'm trying to create a string of length 5. My current group is providing me 2 number of characters, max of 2 number of characters, right? This is my current group which is providing me. So what I can do is, if I have to create a string of length 5, then I can add 2 characters into 3 or 1 characters into 4 to make a string of length 5. But if there is a string of length 2, 1 or 0, maybe I will just ask for 2. If you have a string of length 2, even if I add all these 2 characters, it is going to create a string of length 4 and not 5. So what I will do is I will say, okay, initially I can say that dp of length is equal to prefix sum length minus 1. But if the length which I am trying to create minus the group size, that is length I am trying to create is 5. The group size as of now is 2, right? If this 5 minus 2, the value is actually equal to 3, right? So we can actually go till 3. We need to go to 2. Because for the string with length at most 2, we cannot make it a string of length 5, right? This number 4, which I am trying to put it here, this number 4 includes all the strings which are of length 0, 1, 2, 3, 4, right? I cannot convert a string of length at most 2 to a string of length 5 using this group, and that's how I can find out is, I can say the current length which I am trying to create minus the group size is 2, minus 1 more. Because group size, when you say minus 2, it will take you to 3. 3 is allowed. It can be converted to string of length 5. So I have to go one step behind. So I would say length minus group size minus 1. This is length minus group size minus 1. And if this particular value is more than or equal to 0, if it is more than or equal to 0, if it is 0, 1 or 2, then we know that maybe we have some values, we have some strings which are of length at most 2, which cannot be converted to a string of length 5. So maybe we will have to say, okay, 4, we are taking it here, but it should be 4 minus this 1. So I would say if this particular value is more than or equal to 0, then the dp of my current length, which I assigned with this value, will not be correct. This will now be actually equal to ps of current length minus 1. Ps means the prefix sum, but from this we will have to say minus ps of length minus group size minus 1. Basically this particular value, right? So I would say 4, the prefix sum of 4 is 4. 4 minus prefix sum of 2 is 3. So there are not 4, but 3 ways to create a string of length exactly 5. And similarly, to create a string of length 6, you will have to say, okay, for 6, the current group size is 2. It is going to provide me 2 characters, right? So from 4, I can go to 6. From 5, I can go to 6. But from 3 characters, I cannot make a string of length 6 using this particular group. So I would say 4 minus 3. That is, I just have one way to create a string of length 6, right? So this will be 1. And this is nothing but coming from the formula, because length is 6. We are trying to create minus 2 minus 1, which is 3. So ps of length 3 will be minus, and ps of length minus 1, which is 5. Ps of 5 will be plus. So ps of 5 is 4, ps of 3 is 3, 4 minus 3 is 1. So there is one way to create a string of length 6. And that string is nothing but this one, A, B, B plus CC. Right now our group is CC. So now the prefix sum will be, this will be removed, and the prefix sum will be 0, then 0, then we have 0, then we have this 0 plus 1. So this will be 1, then 1 plus 3 is 4, 4 plus 3 is 7, 7 plus 1 is 8. This is our prefix sum. Now let me get rid of this and let me now again try to solve it for the last group we have. The last group is nothing but D, that's the fourth group, and currently all the values will be reset to 0, right? Now again the same question, can you create a string of length 1? Okay, we do not have a string of length 0, so we cannot create a string of length 1. Similarly for 2 and 3, we cannot create a string of length 2 and 3, but we can create a string of length 4 because we have a string of length 3. We have at least one string with at most length of 3, and that string is ABC. Yes, we can create a string of length 4 because for prefix sum length minus 1, that is 4 minus 1, which is 3, we have a value as 1. So there is one string with length at most 3, and that string is ABC. From this group, I can add a D and make it a length of 4. That's the one possibility we have. So this will be changed to 1. Now for this particular 5, you will have to search for 4. You have 4 ways to create a string of length 5. And yes, the thing is, if you say 5, that's the length we are trying to create. 5 minus the group size is 2 minus 1, which is nothing but 2. So for 2, we have 0. Okay. So we actually don't have a string of length 2. So we don't need to worry about, reducing anything from this value 4. Now, how many ways you have to create a string of length 6? You have 7 ways, right, to create a string of length at most 5. But there is a string of length at most 3. There is one string, and you cannot convert a string of length 3 to length 6. So I have to say 7 ways are there to create a string of length 6. But I have to minus 1 from this, so it will be 7 minus 1. So there are exactly 6 ways to create a string of length 6. If you do the prefix sum, this will be 1, this will be 5, this will be 11, right? Because 5 plus 6, 11. Now, the final prefix sum we have is, this is 0, this is 1, this is 5, this is 11. This particular value is telling me that we have 11 number of ways to create a string of length at most 6. We need to find out what are the strings we can create of length 7 and 8. Total strings are 16. There are 11 strings with length at most 6. So the remaining 5 strings are going to be having a length of 7 or 8, right? So this is how we are trying to solve this problem. And yes, guys, this question was big. The solution approach was big. But try to understand it step by step. It is actually very easy to understand if you try to understand it one by one. And honestly, it took me a lot of time to understand the solution. But after giving some time to this question, I did understood it. So it took me like 2 to 3 hours just to, understand and solve the problem. And then for creating this video, it took a lot of time as well, which is fine. I hope this video is going to help you. Let's get back to the solution now, and let us see how the solution of this particular problem looks like. So what we are trying to do is we are first trying to create a variable mod, which is what the question says, that you will have to return the result with a mod of 10 to the power 9 plus 7. So we have initialized this value. Then we have created a variable n, which is equal to the length of the words. Then we have created the groups. Now to create the groups, there are multiple ways. I am using this itertools.groupby function. Using the group by function, I can create different groups I want to create. For example, for this particular given word, this particular g length will be nothing but an array of 4 elements, 2, 2, 2, 2. Basically, all these 2's are the length of our different groups, AA, then BB, then CC, then DD. So this is what I'm trying to create here. This is the logic for this. And you can just use a loop, but I prefer this group by. Now, initially, the total number of ways are 1. And what we are trying to do is we are trying to say for g size, that is the group size in the group length, we have the total number of ways is equal to total number of ways multiplied by the group size, then take a mod, because we need to return it with the mod. So here we are calculating the total number of ways we can create the string. Then if the length of the group length is more than equal to k, that is this particular value is the minimum length string we can create, right? So if this is true, then you can directly return the value of total ways, and if it is false, then let us proceed ahead. Initially, we create the prefix sum of size k, and initially all the values are going to be equal to 1. Then for the group size in the group length, we are going to process each of the group size, and for each of the processing, we are going to say our DP table will be 0, set to 0, will be a list of length k. Then for the length in the range of 1 to k, we are trying to update the value in our DP table for the length 1 to length k minus 1. So we are running a loop in the range of 1 to k. DP of current length is equal to prefix sum of length minus 1. This is something which I explained you while I was trying to explain you the solution approach. There is one more check, that if my current length, which I am trying to create, minus the group size minus 1, if this value is more than equal to 0, then the DP length will be the current DP length minus the prefix sum of length minus group size minus 1. Also take the mod of this value so that you do not create a value which is very, very big. Then you create a prefix sum which is initially 0. The first value will be equal to the DP of 0. And then you can just update the value of your prefix sum using the new DP table we created. It will be equal to prefix sum of I minus 1 plus the DP of I, and again taking the mod. After coming out of this loop, you will have the count of the maximum number of strings we can create of length at most k minus 1 in your prefix sum array. You can just say total number of ways minus prefix sum k minus 1. This value will give you how many strings you can create of length at least k. Just take the mod of it and return it. And this is going to pass all the test cases. I know the solution is big. Do not focus on the solution. It is easy. Focus on the solution approach, which I have explained you. So you can just submit the code, and now it will pass all the test cases. So yes, you can see the runtime is fairly good. The memory used is pretty fine. So we have solved this particular problem. And I think that's it for this video, guys. If this video helps you to understand the problem and the solution approach as well, then make sure that you hit that like button. And honestly, guys, it took a lot of efforts to create this video. then I hope you subscribe to the channel as well, and I will see you guys in the next video. I want to see you guys in the next video. Thank you for watching this video, guys.